This meeting is being recorded.
For Chapter 5, Problem 4, we are asked to identify all the chiral centers in each of these following compounds. So we have a total of 4 compounds that we'll work through. And let's remind ourselves here. So a chiral center, we're going to identify all of the carbons with 4 different groups. And we can use a couple of shortcuts here if we ignore all sp2 and sp hybridized carbons. So we know right away that they do not have the possibility to have 4 different groups because they only have 2 or 3 hybridized orbitals. And then we have all CH2 or CH3 groups because each of those carbons have either 2 or 3 of the same thing bonded to them with hydrogen. So let's take a look here at these compounds. So we have this carbon here in compound A. We would ignore because that has that is a CH2 group. Then we take a look at this carbon here. So going to the right is different than going to the left. So we know that those are 2 different groups. The oxygen atom is a third, and then our 4th different group would be a hydrogen. So this first site that is circled here, this is a chiral center. Then if we move to the next carbon, we're going to circle this one also because we know that we have 3 different pathways, one to the left, one up around the ring, one down around the ring. We know that they're different because they encounter different atoms. One encounters an oxygen, one encounters a carbon, and then going down would encounter a carbon that's double bonded. And our 4th group would then be a hydrogen. So both of these are chiral centers in compound A. Let's keep going. So we have sp hybridized carbons down here. So we'll eliminate those as possible centers. And then right here as well. So we have 2 chiral centers. So this one here, we would say there are 2. Let's take a look at vitamin D and see if we can do something similar. Coming from the left, I'm going to eliminate these 2 and this carbon as well because they are all CH2 groups, but I am going to focus on this one here. We'll circle this one and we'll confirm going up around the ring, down around the ring, they will encounter slightly different paths. Going around the ring. So those are 2 different groups. The oxygens are 3rd, and then a hydrogen we know would be our 4th group. So this is our first chiral center, this circled group. Then we have sp2 hybridized carbons here, so we can skip over these, continue skipping over these as well because they're all sp2s. Now let's look at our ring. Or rather they're all sp2 hybridized. Then we have some CH2 groups here, so we'll eliminate those, eliminate these. This is a CH3, CH3, CH3. We'll keep going, CH2, CH2, CH2. Then we come to these carbons here. We'll come back to a left to right orientation. And this one here, we know there's a hydrogen and then 3 different paths. So this is our 2nd chiral center. Up above here, instead of a hydrogen as our 4th group, we have a methyl group. But nonetheless, we have 3 different paths from that site. So that's our 3rd chiral center. Here we have a hydrogen. So we have 3 different pathways plus a hydrogen. And then we have here our last chiral center. So we have 5 total in this compound, and I didn't eliminate this one. I'm going to box it in instead of circle it because it is not a chiral center. But the reasoning is we have 1 pathway here that's different. We have a hydrogen, but here we have 2 methyl groups. So because of that, we would also eliminate that last carbon there. So we have 5 total chiral centers in this compound. I'm going to move a little faster and identify, we're going to have, let's see, a total of 5 chiral centers again here. And we'll eliminate any of those CH2, CH3 groups. So here, this would be our first site. This would be our second. This would be our third. This would be our fourth chiral center, and then this one here would be our fifth. So confirm that you know why, right? They have four different groups. Some have hydrogens, right, as their fourth group, like these guys here, and then others have a methyl group. So this again has five chiral centers in this compound C, and then our last compound here we'll work through a little quicker. So this site here, again, I'm going to box because it's incorrect. You may be tempted, but notice that we have two phenyl groups here, so that would not be a chiral center. This compound you would work through, you would see either sp2 hybridized carbons in the benzene ring, some methyl groups, CH3, CH2s along here, more CH2s, etc. So we would eliminate all these possible sites except for this site here. So this compound, the last one, fexofenadine, only has one chiral center.